Determine whether the point 19 minus 12, 17 lies on this vector equation line. Okay, so if it lies on there, then I can just look at, say, the x coordinate. 19 must equal 4 plus 3 lambda, which we can solve to give 3 lambdas 15, so lambda must be 5. And then now there's two ways you can do it now. You can either solve for lambda for y and z and see if you get the same thing each time, or you can find the coordinate when lambda is equal to 5. Which I'm going to do, I think. 4 minus 2, 7, plus 15 minus 10, 20. And this is going to give 19, which obviously we solved for that, so that had to be correct. Minus 12, which is also correct, but then 27. So therefore, 19 minus 12, 17 does not lie on the line. Since 19 minus 12, 27 does. Okay, let's take a look at the next part. We're given a couple of vectors, and we're asked to find in degrees the angle between them. So I can draw these vectors like this. I mean, this is just a little sketch. This is the angle in between. It might end up being, by the way, an obtuse angle. It could be that the vector's actually going that way and you get an obtuse angle, but we'll find out. It doesn't matter too much. The key thing is we can use the dot or scalar product. A dotted with B can be shown to equal the magnitude of A times the magnitude of B times cos of the angle in between them. So A dotted with B, I just times the x components, gives me minus 3, then the y components, minus 12, z components, plus 4. That must equal the magnitude of A, which I can use 3D Pythagoras for, so just 1 squared plus minus 2 squared, that's 4, plus 2 squared, that gives me root 9 or 3. Magnitude of B is then minus 3 squared, plus 6 squared, plus 2 squared. Gives me root 49 or 7. So sort this one out. I've got minus 11 equals 21 cos theta. So cos theta is minus 11 over 21. Hence theta is 121.588. Or to three significant figures, 122 degrees. Then asked to find a vector which is perpendicular to both A and B. So for this, I can use the vector product. I, j, k, and line up the first vector along the second row. So I'm going to get 1 minus 2, 2. And then the other vector, minus 3, 6, 2. And I can expand this determinant. It will necessarily give you a vector perpendicular to both. So expand it along the first row. I'm going to get I times the determinant when I cross this out, minus 2, 2, 6, 2. This one's a plus, and then the next one will be minus, and the third one will be a plus. It's minus 1 raised to the power of the row plus the column. So minus j, cross this out, 1, 2, minus 3, 2, plus k, 1, minus 2, minus 3, 6. It's got to be careful here. Minus 4, minus 12, that's minus 16i. Then minus 6, minus 2, that's minus 8j. And then 6 minus 6, actually that's going to be 0. So we just get minus 16i minus 8j. I could write plus 0k just to make it really clear. And that's it.